Alright, so for this question, these are 19C.1. One, a local zoo starts a breeding program to ensure the survival of a species of mongoose. Now, I just always like to highlight the important information. Using results from a previous program, the expected population in N years' time is given by this function over here. What is the initial population purchased by the zoo? So 1A, in order to do that, now initial means at the start. That means my time hasn't started. So my time becomes 0. So in this case, my time is in n equals 0. So all I have to do is substitute that value into the function. My function that I got given is p equals 40 times 1.15 to the power of n. So I always like to start with writing it. And then I go substitute it into the function. So this is what p of function 0 means. And then 40 times 1.15. And instead of writing n, I write the 0 in. I substitute that value in. Then all I have to do is put it in the calculator, or hopefully you know that 1.15 to the power of 0 is just 1. So it just becomes 40. And you need to make sure you write units. Now this one, if I go back and reread the questions, and especially the highlighted parts, I should know that this is 40 mongoose. This is the population they begin with. Alright, so B, let's try B. So BI is find the expected population after 3 years. All that means is it's not at the initial anymore, it's after 3 years. So my n is 3 because it's 3 years. So again, I use that normal function, put a 3 instead of n. And that's all I have to do. All I have to do is just chuck that in the calculator, and I'll just leave that for you to do it, because I don't have my calculator with me. And then what I'm going to do is I is just p, and instead of n years, I put a 10 in there. So 40 times 1.15 to the power of 10, and use your calculator to find the answer. And for I just do p to the power of 30 years. And then go 40 times 1.15 to the power of 30. Now I'm just going to quickly look at the answers so I can do the part C. So I've got my answers here, so I'm just going to copy it down. So when you do n to the power of n equals 3, you should have approximately 61 mongoose. This one should have been approximately 162 mongoose. And this one should have been 2,648 mongoose. So hopefully you found that using your calculators. Right, now what I have to do is sketch the graph P against N using all the information I found. So the most important part you need to know is to do the axes properly. This is going to be my graph. And I need to make sure my smallest number and my biggest number fits on the graph. So I need to get the scale right. So let me have a look at what my smallest numbers are. I'll highlight them. So 40 mongoose is my smallest number. I've got 2,648, which is my biggest number. So I'm just going to go up in maybe 500 or something like that. So that's going to be my 500. That's going to be my 1,000. That's going to be 1,500. That's going to be 2,000. And then 2,500, and then about 3,000. So mine's going to be a very small graph because that's the space I had, but in the test, make sure it's kind of big, and the bigger the better, pretty much. Alright, so I've got my population scale, so I really like to write that in, so I'm going to use black. My population is in mongoose, so I like to write the units as well, P mongoose. Alright, so that's my y-axis, technically, and my x-axis is n, and it's measured in years. So there we go, that's how we write it. Alright, so let's do my x-axis. It's 0 to 30, so I'm going to maybe do 10, 20, oh, that's a bit too small. I'm going to make it a little bit bigger. Maybe I'll do 5, 10, 15, 20, 25, 30, so it's a little bit bigger. Right, now all I have to do is draw the dots. So my 0, when my n is 0, my p was 40 mongoose, which is essentially like really at the bottom compared to 500. Alright, so when my graph is at n equals 3, which is about here, excuse me, then my answer is 61 mongers, so it goes up a little bit, just a little bit. Okay, now I have 10 mongers, which gives me 162 mongers. 10 years, 162, so it goes up by a little bit. And then 30 years, it's at about 2,648, which is about here. All I have to do is connect the dots. Obviously, hopefully your graph is looking a little bit better than mine because mine's scaled very loosely on the y-axis. Now once I draw it, all I have to do is add in the function. So p equals 40 times 1.15, and that's really it for the graph.